Ken Forster, Executive Director at Momenta. Welcome to our Digital Thread podcast, produced by, for, and about digital industry leaders. In this series of conversations, we capture insights from the best and brightest minds in digital industry. They're executives, entrepreneurs, advisors, and other thought leaders. What they have in common is, like our team at Momenta, they are deep industry operators. We hope you find these podcasts informative, and as always, we welcome your comments and suggestions. Good day and welcome to episode 209 of our Momenta Digital Thread podcast series. Today, I'm greatly pleased to host John Hart, professor and department head of mechanical engineering at MIT. He is also the director of the MIT Center for Additive and Digital Advanced Production Technologies at MIT. John's research group aims to advance the science and technology of manufacturing in areas including additive manufacturing, nano-structured materials, and the integration of computation and automation in process discovery. He also teaches undergraduate and graduate courses in manufacturing processes, advanced materials, and research methods. Through various digital channels, videos of his manufacturing lectures have been viewed millions of times, and over 100,000 individuals have enrolled in online courses that he leads. He's also a co-founder of VulcanForms and Desktop Metal and a board member of Carpenter Technology Center. John, welcome to our Digital Thread podcast.
Thank you, Ken. It's great to be here, and I'm looking forward to the conversation.
As well, I know we've been in a long time prep for this, and so I'm glad we were able to finally find a time to secure for the conversation. So, we call this the Digital Thread podcast, and the focus really is one's almost personal digital thread that leads them to where they're at now. So what would you consider to be your digital thread? In other words, the one or more thematic threads that define your digital industry journey.
Yeah, thanks. It's a very interesting question because honestly, I've never thought of the idea of having a personal digital thread before, but it's very true that I've always been interested in both the digital and physical, even though only relatively recently did I start thinking seriously about how to put them together. But journey-wise, maybe there's three quick points. Like first, I always feel that my career has been touching a lot of really fortunate opportunities and has been one of organic growth and exploration. I've never had a goal to go to a top of a specific career mountain, so to say, but it's more been of a journey through different organizations and complementary areas of research and so on. The second point is, I think a theme running through it, however, is how to scale. So to me, manufacturing is delivery of value at scale. So I've always been interested in taking ideas and exploring through research and entrepreneurship and other paths, how to bring new things to scale. And that is on the technical side, it's on the education side, and more. And last, once again, combining the physical and the digital. It doesn't need explanation, especially to this audience, but we live in the physical world, and the embodiment of digital technology, especially in production systems, is to accelerate and enhance the physical technologies that drive our daily lives.
I really like the way you answered that. And it's interesting, the manufacturing being defined as the delivery of value at scale. That's quite astute. What I really appreciate already when I started to look in your background is that you started at General Motors. And so working across several engineering groups, how did this early work inspire you to pursue your academic direction?
So I grew up in the Detroit area and was an undergraduate at the University of Michigan. And I can't say I was really into cars nor the automotive industry, but honestly, studying engineering at that time, starting my undergraduate in 1997, there was a place to go. So I was looking for a summer internship and was fortunate that General Motors offered me a job. And I ended up doing 3 consecutive internships there, including one after my first year of graduate school, which was at MIT. And I enjoyed the experience. It was great to be working with skilled engineers on manufacturing system design, and actually one summer largely on the plant floor in Mexico, scaling up the production of the Pontiac Aztec. I was charged with running around the factory floor and looking for defects or finding lost parts, things like that. But it more so taught me that I wanted to go to graduate school and learn more, especially the interface between design and manufacturing. So in a way, I feel like I've come a little bit full circle, not necessarily to the automotive industry and mobility, but I really feel strongly about working deeply with industry from my main role as an academic. But in one way, my industry experience nudged me toward a more academic or research-oriented career path for ultimately a PhD and then becoming a professor.
I think what I appreciate also about your background is you've done a fair amount of work in startups. In fact, you co-founded 3 startups, Absolute Nano, VulcanForms, and Desktop Metal. Can you tell us a little bit about each of these?
Yeah, of course. So Absolute Nano was honestly a small business. Not unfair to call it a startup, but Absolute Nano built and sold systems for desktop materials processing, specifically for the growth of carbon nanotubes, which was a topic of my PhD research in mechanical engineering at MIT. And we had the opportunity to turn it into a small business because when I published the work with colleagues, of course, there was interest from other universities and some research labs in adopting the equipment, and was fortunate to have some friends outside of MIT and ultimately future students when I started as faculty, which was actually back at Michigan, who were willing to commit some spare time to building the systems and fielding them and servicing them. And we probably sold a couple dozen at most, but it was a good experience. I honestly, at that time, didn't consider it a startup like I think of startups or entrepreneurship now, but we also got an SBIR grant and we ultimately sold the business. Not a huge exit, just a way of transitioning out of it several years later. But it was a lot of fun and sort of showed the importance of physical tools in pushing the boundaries of laboratory research. And now we think about combining AI with automation and precision engineering and so on. So it's another way that I think a lot of the activities I've been involved in have built upon one another, even though maybe the application or the domain has changed. And Desktop Metal and VulcanForms are 2 kinds of companies focused on 3D printing / additive manufacturing and digital manufacturing. So VulcanForms was founded by myself and a former graduate student at MIT, Martin Feldman. He and I actually met in his first semester as a master's student and my first semester as a professor. So it's a good story. And I, in that first semester, ended up somewhat serendipitously deciding to teach an extra course, a small course on 3D printing, because it was an area I was interested in learning more about. And I saw it very connected to my passion, which is manufacturing, but it was a new direction. And Martin was in that course as a member of our Master of Engineering program. And one thing led to another. He ended up staying in my lab and we founded VulcanForms together in 2015. I should probably roll back and say what VulcanForms does. We have built and scaled a digital production system to create engineered products and solutions. Specifically, that means precision metal components that leverage digital production technologies for their performance and for a streamlined, efficient supply chain. And through that, we built a core technology for laser-based metal 3D printing that's the cornerstone of this production system. And Desktop Metal was founded shortly after VulcanForms. Honestly, I think I was in the right place twice at the right time, but jumped at the opportunities that came in front of me. And I was one of the 7 co-founders of Desktop Metal, led by the CEO, Rick Fulop. And that company has built and fielded a number of 3D printing technologies and continues to grow. Went public in 2020, late 2020, and now is under agreement, even though I'm not working with the company day to day anymore, but is now under agreement to merge with Stratasys, which I believe will form the largest publicly traded 3D printing / additive manufacturing company in the world, which is super exciting. And all of this stuff is at the very early stages and there are lots of challenges, but it's been such a joy to be involved in the industry for the past 5 to 10 years and feel like I can have a role at expanding the capabilities and creating value for the building better products that matter.
I find it interesting that you identified yourself a few minutes ago as an academic. And given the track record that you've had, both coming from industry, but also forming these companies, in some sense makes you feel like an entrepreneur that happens to teach versus a teacher or academic that happens to do startups on the side. But I do like the fact that versus pure research, it feels like you work a lot on the development or application side of that as well. So I'm curious, what have been some of your key insights relative to founding and scaling deep tech startups? And how have you woven these into your courses and research?
My main insight is that it's a feedback loop. And MIT is a wonderful place to have the opportunity to build teams and intersect with others who want to take a technology to market. And I would not be involved with DM and have, nor would I have had the opportunity to co-found VulcanForms if I was not at MIT. And that's a testament to the belief as an institution and among our community, faculty, students, staff, alumni, that you can start with an idea, whether it be from the lab or just on a whiteboard, and you can see the opportunity to take it to market, whatever that path may be, and you can bring together the people and the resources, the funding, the perhaps complementary technologies and business partnerships to move to the next stage. So in terms of key insights, I certainly think more in the early stages of research about where an idea could go. And it's sometimes a delicate balance because you don't want to constrain first early stage research too much, right? I'm not a scientist, so I don't work on sort of really basic fundamental questions, which are always so important. But even at the early stage of engineering or engineering science research, you want to have a lot of freedom up front. But it's valuable to think about where an idea could go and how you can shape the trajectory of your research, and particularly what questions you should answer at different stages to maximize the possibility that it could go forward, or determine this was an exciting idea, we did some good research, but let's focus on other things going forward. And also, you need and should reach out to give advice and support, whether that's a co-advisor for a graduate student or a co-founder of a startup or your next employee, you name it. So bringing that ramble all together, I feel it's a very important, and it's been a valuable feedback loop to me. And I hope I've been able to transfer some of that experience to my students and other collaborators.
Clearly you have. You mentioned earlier, happened to be in the right place at the right time. I think opportunities are largely created, and it feels like you've created the ecosystem and environment to spawn such opportunities and happen to benefit from it as well. So let's talk about that, especially at MIT. So in 2018, you founded the MIT Center for Additive and Digital Advanced Production Technology. So what's the focus of this program, and what have been some of your wins?
Thanks for asking. So the focus is to bring industry together with us at MIT to discuss the trajectory of additive and digital manufacturing, like broadly defined, but also with a lot of 3D printing and materials and machines. And therefore, to learn as a group and to solve problems collaboratively, with hope that the members take away knowledge and insights that they can go deploy internally to grow their strategy and extract more value. And another focus has honestly been to create a community around additive manufacturing on campus. We, as MIT, have hired more faculty working in different dimensions, materials, mechanics, structural design, optimization, so on. And additive and digital manufacturing, of course, is such an interdisciplinary field. So I hope that this center or consortium, which is really a small effort, to be honest, has been valuable in that regard. And one of our biggest areas of impact has been education. We've launched, working with MIT XPro 5 years ago, an online professional course, which has enrolled over 7,500 professionals, and that's had a great impact, and we've gotten a lot of positive feedback from it. And also, we're in the process of now designing, building some new labs with a host of these technologies and a full digital thread from end to end that is supported by many of our industry members in terms of in-kind contributions of equipment and donations thereof, as well as a $4 million grant from the state of Massachusetts. And that's a perfect example of partnership between industry and MIT and external agencies, in this case, the state of Massachusetts, who are investing in us because they want to see this new technology implemented in the industrial base in Massachusetts and New England. And we're very dedicated to that, as well as educating our students and pushing the boundaries of research that will, frankly, take a long time to reach the light of day.
Speaking of impactful initiatives, I know you recently kicked off manufacturing at MIT. So an MIT-wide effort to stand up a new initiative on the future of production. Can you tell us a little bit about the program and goals?
Yeah, of course. And thanks for asking about that as well. I guess we have a lot going on, but many inputs, including our experience with the Additive Manufacturing Center, which continues to go on, led myself and several colleagues about 18 months ago to say, what could we build at MIT that represents manufacturing across the institute? So we are working to stand up a new initiative at MIT called Manufacturing at MIT, and Not unlike the additive domain, the goal at a broader scale is to bring together the MIT community and partner organizations to study the future of manufacturing. And therewith, a big focus on understanding how to bring new production technologies and new production systems to scale. And the governing theme is it's not just the technology, but it's the overall system, of course, and people and the workforce and so on. So I could say a lot about it, and I don't want to be too long-winded, but one further point is we're organizing our efforts around 4 grand challenges or 4 themes, which are scaling digital technology, building a skilled workforce, rethinking lean manufacturing for resilience, and achieving sustainability and circularity. And, it matters, not just that we're interested and we have shared interests, but actually what do we learn? What can we demonstrate in terms of case studies and roadmaps? And how can we connect those to research and technology development opportunities in specific industry areas, semiconductors, biomanufacturing, mobility, AI and production overall. And in those domain areas, that's where folks at MIT are really excited, and my colleagues are all doing groundbreaking work. So we want to bridge that gap and sort of have a front door where we at MIT can contribute to what the country and what the world need, because bottom line to me is like manufacturing drives daily life. So it needs to evolve and grow and help address the greatest challenges we face, including, achieving a low carbon economy and saving the planet.
I'm glad you brought up those points because I think we've been very much involved in the Industry 5 initiative, and I know we've made some introductions there for you as well. In fact, I got a kick that 3 out of the 4 of your grand challenge themes line up really well with the planks, if you will, for Industry 5. But the key there is there's a large impact that you can have in industry on sustainability, certainly resilience and human centricity, as they call it, because it is a majority of usually the population's employ. It generates our energy. It generates our consumer goods. It generates, capital goods. And if there's a place to make a difference, digital typically is the enabler for ESG style goals. And so that impact is fairly large that you can have carbon efficiency, as you said, and others. So I think it's an interesting tie into this. You mentioned country a moment ago. Why is this program needed now in the U.S. in your mind?
The U.S., in my opinion, and I take this from the inspiration of my colleagues, Professor Suzanne Berger, David Mendel, and others, the U.S. has lost the connection between product and process innovation. Full stop. For a long time, we offshored a lot of production. I think there are good reasons for that in many cases, especially at the time. But product and process innovation go hand in hand. And if you do not manufacture enough locally, nationally, it is harder over time to maintain a competitive advantage in developing the next generation of innovative products. And as a result, we in the US need to rebuild large parts of our industrial base. We're not going to bring it all back. We're not going to fully deglobalize, et cetera, whatever the word is. But that's really important, and it's important to our sustainability, environmentally, economically, and our national security, and to the opportunities provided to our people, right? Having good jobs, et cetera, et cetera. So it's incredibly important and, to me, exciting layered problem to work on. And it's not a one-year problem. It's not a 10-year problem. It's a multi-decade continuous evolution that we have to buy into at all levels of society and government and all the things we're talking about today.
I think you've tapped into a bit of a zeitgeist. We may refer to it as reshoring or deglobalization, but I know there's been several books as of late, Titanium Economy by McKinsey, Chip War, of course, talking about, the semiconductor industry and such. So I think it's an interesting time to be having these discussions and for you to be having the impact that you are. I sense this is a global conversation. And so I'm curious, how do you plan to work with organizations outside of the US, such as the EU?
For sure. So with respect to the EU, we're exploring a number of formal and informal collaborations with organizations in the EU. Above all, I think we can learn a lot from one another. I've learned recently from visitors we had at our symposium in May from Loughborough University that the UK faces many similar challenges as the US in terms of the decline of its industrial base, and has some really exciting approaches and programs to cultivate digital transformation of small and medium enterprises. That said, there are also some unique perspectives. I think a much stronger perspective on circularity in the industrial economy, in part because the UK has a far less raw material supply than the US. And turning to Germany, as many folks know, Germany is a leader in manufacturing workforce development. And a number of our colleagues recently participated in a trip to visit the vocational schools and universities in Germany. And last thing I'll say here is, in my opinion, as putting my sort of research professor hat on, the EU has very effective models for translational research with industry and manufacturing. The Fraunhofer Institutes have been a model for the Manufacturing Innovation Institute / Manufacturing USA, the network in the US. And I see many exciting EU-funded projects, research projects that have both basic research in manufacturing, process science, and translational aspects involving companies and startups. And sorry, one more thing. I also feel that the EU is eager to learn more about how the US is entrepreneurial and how we fund startups and how we scale startups and so on. So nothing necessarily specific yet, but really excited to form those bridges and collaborations, because we got to work together across the oceans in addition to focusing on our own countries and economies.
Yeah, clearly. It's interesting, as you said, there's certainly a lot of lessons the US can teach Europe relative to entrepreneurship. I think one of the certainly benchmarks for labor is really the EU or European, if you will, apprenticeship programs, right, for developing skilled labor. And I know the US had much stronger apprenticeships back in the day, but it feels like, as you say, it's a time to consider those as benchmarks as well toward the next generation of manufacturing and digital personnel. Let's go back and talk about reshoring. This, of course, has been a key trend in North America and Europe. What do you and your colleagues at MIT see as a driving force for reshoring, and what manufacturing should be reshored?
Another great question. Thank you. So maybe in no particular order, what are the driving forces? One, national security. And I'm not just talking about defense manufacturing, but we saw during COVID the importance of manufacturing to the security of our people, our economy in the face of a pandemic. And as COVID hopefully gets a little bit farther away, I'm a little bit hesitant to make the COVID analogies because these themes should stand the test of time, but certainly that was a learning experience. Along with that comes the need for resilience. We've seen how fragile supply chains are. And back to this theme of manufacturing at MIT, like rethinking lean for resilience, to expand a bit there, the idea is that lean production has been the governing principle of the past 30 years. And it's not going away. And it's an operational, organizational principle to be efficient. But we have to ask the question, how do we build more resilient production systems while maintaining lean? And it's an area where I think, in general, these digital technologies for monitoring operations, for predicting what might be needed, predicting how a supply chain could respond, connecting members of a supply chain can be very powerful. And third, in terms of a driving force, the ability to move fast. So it's one thing I think I could kind of separate resilience. If I have a system, is that system robust to disturbances? If I want to move fast in developing new product, if I can do things even just at a pilot stage of production locally, then I can build the networks that allow me to innovate more quickly. And we can't rely on globally distributed supply chains to do all of that. And I think you asked what kind of manufacturing should come back. Well, not all manufacturing. I don't have a complete answer to the question, but I think some key drivers are types of manufacturing that, of course, that fit the criteria above, but also can involve a high technology content in the production system and are enablers to and/or can be driven by greater sustainability. And I'm hopeful that a drive toward decarbonization of supply chains can be a positive driver toward more manufacturing in the United States and in many places, locally and regionally around the world. Because we have to rebuild, and when you have the opportunity to rebuild, to make something more sustainable, maybe you can rethink how to shift your capabilities and your operations as well.
The greenfield, right? It seems that most manufacturing opportunities, especially on the digital side of it, are pretty much brownfield. And the beauty of a lot of the reshoring initiatives and new matrix supply chains is a chance to create new. And as you say, there's a chance to leapfrog in terms of technologies, but also in terms of sustainability goals too. I like your term, rethinking lean. It could be an interesting topic for a later podcast. So
For sure.
How can our listeners get more involved in manufacturing at MIT?
Number one, follow us on LinkedIn. We only have LinkedIn as social media now, but just search manufacturing at MIT. I'm manufacturing with the @ sign and then MIT right after it. And feel free to reach out to me, ajhart@mit.edu, if you're from a company that's interested in seeing what we're up to, or a university, and either of those would be awesome. I welcome interest from anyone.
Great. I know Momenta is happy to be involved and looking forward to expanding our work with you guys as well, because I think it's the work you're doing is impactful and meaningful. So in closing, I always like to ask, where do you find your personal inspiration?
So honestly, I don't have a central source in terms of a book that I loved or a methodology to it, but I do what I can to follow a broad set of inputs. New York Times, the information, various podcasts, occasional books on management, technology, sort of personal growth. There are, however, two things that I read that inspired me a lot starting in 2020 and have informed all of the thoughts I've shared with you today. So the first is a short essay that you can find online called "It's Time to Build." And it was written in the first half of 2020, I believe, by Mark Andreessen, who's A16Z, a large venture investment firm, and back in the day, co-founder of Netscape. It's all about the importance of building the physical world to our everyday lives. And second, I honestly stumbled into the concept of architectural innovation, which was advanced in about 1990 by Rebecca Henderson, who is now a distinguished professor at Harvard and at Harvard Business School. And she has a fantastic article, which maybe we can post below the episode, called, I believe, Architectural Innovation in the 21st Century. And it's all about building teams and organizations with authentic purpose to go tackle really hard problems. And it has elements of lean manufacturing in it. It has elements of promoting diversity and strong communication. But the overall idea of architectural innovation, if you're not familiar, is that most impactful technologies and companies come not from singular innovations or inventions, but come from reconfiguring pieces at the system level. And that, to me, is a very powerful theme, and looking back applies to some of the things I've been fortunate to be involved in and accomplish, but also I think is really an imperative for the future, where I would be willing to bet that most of the solutions to climate change technologically are already in front of us. Many of those we need to bring to scale and solve lots of great engineering challenges, whether it be fusion or geothermal or better photovoltaics and all of the above. But we need to implement and build the systems that create different pathways. And I also look back at what I consider to be the most impactful companies of the past 20 years. And I think there's an argument less architectural innovations that changed the way we do things. And that's what made them so impactful.
Two excellent recommendations. And I say excellent because neither of them has crossed my radar before. So we will include links on our podcast recording, and I will make sure to read both. So, well, Dr. Hart, thank you for sharing this time and these insights with us today.
Thank you, Ken. All the best.
As well. So this has been John Hart, Professor and Department Head of Mechanical Engineering at MIT and Faculty Director, Manufacturing at MIT. Thank you for listening, and please join us for the next episode of our Digital Thread podcast series. We wish you a momentous day. You've been listening to the Momenta Digital Thread podcast series. We hope you've enjoyed the discussion, and as always, we welcome your comments and suggestions. Please check our website at momenta.one for archived versions of podcasts, as well as resources to help with your digital industry journey. Thank you for listening.